हेलो गाइस, दिस इज योर केपी सर. हाउ आर यू ऑल? कैसा है बच्चे लोग? So before going to start the session, join full length course on Unacademy to learn in-depth subject of GATE and ESE, to get my proper guidance, and you want to crack GATE and ESE in first attempt. Take plus subscription in Unacademy. Use my code KP Civil or Engineering Guru. This is my code. If you want anything related to plus subscription, anything related to your subject matter or doubts related to you, related to your preparation, whatever you want to support regarding your academics, ping me, WhatsApp me 898593312. I'm ready to support you at any time under any circumstances. So your KPs are with you to crack GATE and ESE. Okay. Now UPPSC AE Part 16, complex hydrographs. Hydrology. We are talking about hydrology. Complex hydrographs. We have completed hydrograph, flood hydrograph, unit hydrograph, direct runoff hydrograph. Even numerical questions also solved related to direct runoff and unit hydrograph. Now we are discussing regarding complex hydrographs. What is a complex hydrograph? Any guess or any related information to you? Do you know anything related to complex hydrograph? Complex hydrograph we are considering a storm of T hour, total duration T hours occurred. A rainfall of T hours occurred. But already you have a D hour unit hydrograph regarding the catchment. For the catchment, you are having a D hour unit hydrograph. Now, this storm of T hour, this is called complex storm. Complex storm. Rainfall of T hours. Complex storm is said to be rainfall of T hour duration. Rainfall of T hour duration. So using this D hour unit hydrograph, already you are having a unit hydrograph for the catchment. D hour unit hydrograph. You are plotting T hour unit hydrograph for complex storm. For complex storm. That hydrograph methods. That is called complex hydrograph. What is the confusion? D hour unit hydrograph, T hour unit. What is the confusion here? For example, already you are having a 3 hour unit hydrograph of your catchment. You are already carrying a 3 hour unit hydrograph of a specific catchment. Now in that catchment, after some number of days or some number of months, there is an occurrence of 6 hour unit hydrograph, 6 hour rainfall. There is an occurrence of 6 hour rainfall. Now I am dividing this 6 hour rainfall of 2 events. Storm 1 event of 0 to 3 hours. Storm 2 event of 3 to 6 hours. So total 6 hour rainfall I have classified, divided, partitioned into 2 components. Storm 1 of 0 to 3 hours. Storm 2 of 3 to 6 hours. So this is a 3 hour event, 3 hour storm. This is another 3 hour event, 3 hour storm. Both storms are applicable, analyzed using this 3-hour unit hydrograph. Using this 3-hour unit. So application of the data ordinates providing this available 3-hour unit hydrograph, which are utilized to plot this 6-hour unit hydrograph. This is called complex hydrograph. This is called complex hydrograph. You understand it? From a storm of D hours already plotted against a rainfall for a catchment, that is called D hour unit hydrograph. Future storm of T hour occurred, that the future storm of T hour obtained using this D hour unit hydrograph. That is called complex hydrograph. When you consider the procedures of complex hydrograph construction or the procedures of complex storm analysis, the procedures of complex storm analysis, it has been differentiated into complex storm analysis is differentiated into analysis of uniform storms, analysis of uniform storms, analysis of non-uniform storms, analysis of uniform storms and non-uniform storms. What is the storm in terms of uniform and non-uniform? Tell me. The storm with the same depth. Both the storms, total T-hour storm each period showing same depth of effective rainfall. Same depth of effective rainfall. For example, storm 1 is showing same depth 2 centimeter. Storm 2 is also showing 2 centimeter. Effective rainfall depth is 2 centimeter and 2 centimeter. Effective rainfall depth is 2 centimeter and 2 centimeter for storm 1 and for storm 2. Same depth. That is called uniform storm. That is called uniform storm. Variable depth. Depth of storm 1 and storm 2 are not same. Variable. That is called non-uniform storms. For example, storm 1 is showing now 3 centimeter depth. Storm 2 is showing 2 centimeter depth. Values are same or different? Varying. Storm 1 depth value is 3 centimeter. Storm 2 depth value is 2 centimeter. Varying. That varying depth is called non-uniform storms. Again, uniform storms analysis. Complex uniform storm analysis will carry out by two methods. First one is method of superposition. Method of superposition. So using this method of superposition, you can divide a complex storm into n equal number of simple storms. Total storm duration, complex storm duration, I am taking total complex storm duration T divided into n equal values of D hours. So for example, 6-hour storm, I have divided into 2 equal values of 3-hour storms. 4-hour storm, I have divided into 2 equal value of 2-hour storms. That is called T is equal to ND, method of superposition. Unequal storms, S curve technique, S hydrograph, S curve analysis, S curve technique, all same. S hydrograph, S curve analysis, S curve technique, all are same. For example, you are having a storm duration of 5 hours. Your hydrograph available is 2 hours. Will you divide a 5-hour total time into equal period of 2 hours? Not possible. So T is not equal to ND. So if you want to convert 3-hour unit hydrograph to 6-hour, 4-hour unit hydrograph to 8-hour, 2-hour unit hydrograph to 4-hour, 6-hour, 8-hour, method of superposition. If you want to convert 3-hour unit hydrograph to 7-hour unit hydrograph, 8-hour unit hydrograph, time is invariable. Time is not divided into equal periods. Time is divided into equal periods? No. 3-hour UH, 6-hour UH, 9-hour UH, 12-hour UH you can plot. But not a 7-hour UH, 8-hour UH. No? That variable time, n number of equal periods, not possible. That is analyzed through S-curve technique. Same concept. Method of uniform storms, non-uniform storms. Analysis of non-uniform storms. Analysis of non-uniform storms carried out by same method of convolution. For what circumstances? When you apply method of convolution, do you know when you apply method of convolution? Yes. Yes, method of convolution is applicable. Same like superposition. T is equal to ND. Then what is the difference between method of superposition and method of convolution? Difference is depth. Depth is varying. Variable depth. Depth is varying. That is the difference here. Here is the same depth. Method of superposition, method of convolution, same. Depth varying with respect to time factor, it is same. Second one, last one in total complex storm analysis. Method of deconvolution. Again, variable depth, variable time duration. Time is changing, depth also changing, variable depth and variable time duration. That is analyzed using method of deconvolution. Same we can take T is not equal to ND. You can't divide a total storm into equal number of D hour storms. You can't divide a total storm into n equal number of D hour storms. That is analyzed. Method of deconvolution, S-curve technique. If depth is the same, S-curve technique, depth is variable, method of deconvolution. So one by one, each and every method I will explain. Don't worry, my dear students. Okay. Method of superposition. So what we are analyzing according to method of superposition, you are having a D-hour unit hydrograph and converting this D-hour unit hydrograph into T-hour unit hydrograph. But conditions are there. Conditions are there. What are conditions? T is equal to ND. And also the total time of rainfall must be greater than duration D. T is equal to ND. T is greater than D. And N value is an integer, not expressed in any decimal values. N value must be an integer, not in decimal value. For example, you can divide. You are having 2-hour UH. You want to extract 6-hour UH. So you can divide now 6-hour storm event into this 6-hour storm event into 3 2-hour storms. Is it possible now? 6-hour storm event 0 to 2 hours. One storm 1. 2 to 4 hours, 2, storm 2, 4 to 6 hours, 3, storm 3. How many storms? 3 storms of equal depth, equal duration, 2 hours. 3 storms. We have differentiated a 6-hour storm into, 3 storms of same depth, same duration. That is analyzed through method of superposition. Three storms, each 2-hour duration, same depth. So that we have differentiated, we can analyze using method of superposition. For example, you have been provided with a 2-hour UH. You want to determine a 5-hour UH. Will you apply method of superposition? Is it possible? No, impossible, not possible. So it is not applicable by method of superposition. Why? T is not equal to ND. N is 2.5 decimal value. So method of superposition not applicable. N is an integer, not decimal value. Then only you apply method of superposition. I will plot the graph. Data is provided to you. D our unit hydrograph provided. Unit hydrograph discharge values. On y-axis considered meter cube per second. X-axis time is taken in hours. Unit hydrograph on y-axis Q. Now we have provided with D our unit hydrograph. 0, D, 2D, 3D, 4D, 5D. Okay. This is D our unit hydrograph. Now you want to convert a D our unit hydrograph to T our unit hydrograph. And that T is equal to, for example, you consider 2D. Okay. I am writing the ordinates, listen carefully. So time is taken 0, D, 2D, 3D, 4D, 5D. And D our unit hydrograph ordinates I am writing. 0, A, B, C, D, 0. Now I want to plot T our unit hydrograph. Where we'll consider T is equal to 2D. So I can divide a total time into how many unit time periods? This is D. This total, what is there? T hour na? This total is T hour. Total T hour I have divided into 2 unit time periods of D hours. So storm 1, 0 to D I am writing. Storm 1, 0 to D. This is 0, this is D, this is 2D. Okay. Storm 1, 0 to D. So we have started, we are getting the values. Where you are getting the values? Same as it is, copy. No change, because storm 1 ended at D hour. So you are getting the values at D hour. 0, A, B, C, D, 0, no change. That means this as it is, you can take storm 1 unit hydrograph, no change. You will consider this as it is as storm 1 unit hydrograph. Now second storm D to 2D, storm 2, second storm D to 2D. What you can write? Second storm D to 2D. Where it started? It started at dth hour, provided data at 2D. So up to 2D it is 0. You understand? It is providing data at 2D hour. So up to 2D 0. So 0, 0 means delayed by D hours. Simple. Delay by D hours. Delay by D hours. So 0, 0. Then you start the value from 2D. A, B, C, D, and here 6D you can take. It is 0. It is started at 2D and ended at 6D. Started at 2D and ended at 6D. So value started at 2D, but 0 started at D. So storm 2 unit hydrograph is like this. Storm 2 unit hydrograph is like this. Storm 1 and storm 2. What happened? Delayed by storm 2. How many hours? D hours. Storm 2 delayed by D hours. Storm 2 delayed by D hours. This is storm 2. We'll write down clearly. Storm 2 unit hydrograph. Storm 2 unit hydrograph. Now I am adding storm 1 and storm 2. Sum. Storm 1 plus storm 2. Some values I am taking. Some values I am taking. Storm 1 plus storm 2. Some values I am taking. What can I write? 0, A plus B, B plus C, C plus D, D 0. This is a storm 1 UH. This is also storm 2 UH. Means unit hydrograph. What is the meaning of unit hydrograph? Storm 1 of 1 centimeter depth, storm 2 of 1 centimeter depth. Both added up. You understand? Storm 1 unit hydrograph of 1 centimeter depth, storm 2 unit hydrograph of 1 centimeter depth. Both added up. So what is added values depth? It is a 2 centimeter depth of rainfall. 2 centimeter depth of rainfall, and this is taken as T hour DRH. This is considered as a T hour DRH. You understand? It is not UH now. You have added storm 1 of D hours, storm 2 of D hours. Total 2D hours, 0 to 2D. That is the T hours. Storm 1 of 1 centimeter, storm 2 of 1 centimeter, total 2 centimeter depth. It is not 1 centimeter depth. So that it is DRH, direct runoff hydrograph. Where it is coming? Show me where it is coming. So now the values are like this. The values are like this. This is T hour DRH, direct runoff hydrograph. Sum of storm 1, storm 2. Then if you want T hour UH, how can you calculate? Simple. T hour UH is equal to T hour DRH. You have obtained in this last column. Na? That T hour DRH by N. T hour DRH by N. What is N? N is equal to T by D. Total duration, UH duration. N is equal to T by D. So what is the T? T is 2D. So N is equal to 2. Na? N is equal to, now according to the given example, 2D by D, 2. So divided by 2, that is nothing but 2 centimeter depth you are taking. You are adding 2 storms of each 1 centimeter depth, DRH. Total depth 2 centimeter. You need for 1 centimeter UH. You need for 1 centimeter UH. Divided by 2 you are doing. So you will get UH values. If I have plotted the UH value, where it come? It is less than UH values of D hour. So this yellow color what I am plotting, T hour UH. So it is the meaning of this. Very important. T hour unit hydrograph discharge values. T hour unit hydrograph discharge values always less than D hour unit hydrograph discharge values. Remember this. Most of the times your UPPSC AE has given theoretical question about this. Very important. T hour unit hydrograph discharge value. T hour unit hydrograph discharge value is always less than D hour unit hydrograph. So this is a T hour unit hydrograph. T hour UH value, because you are divided by N. N is equal to T by D. N is equal to T by D. I will explain it with a numerical example. So that it will become very easy for you. Clear? Just you are delaying for D hours. I will tell you. So take example now. Time 0, 3, 6, 9, 12, 15, 18, 3 hour UH provided. Now the data I am writing, 3 hour UH data I am writing. 0, 4, 12, 15, 6, 0. This is the 3 hour unit hydrograph data provided. For example, there is a 6 hour storm occurred. So plot 6 hour unit hydrograph. Plot 6 hour unit hydrograph using given 3 hour unit hydrograph. Plot 6 hour unit hydrograph using given 3 hour unit hydrograph. So I am dividing this 6 hour storm 0 to 6. This 6 hour rainfall I am dividing into 2 storms. 0 to 3 storm 1, 3 to 6 storm 2. Okay. A 6 hour storm divided into 2 components, 0 to 3 hour storm 1, 3 to 6 hour storm 2. So that we can delay storm 2. Storm 2, how many hours you can delay? D hours. What is D? Storm 2 delayed by D hours. D is 3 hours. Storm 2 is delayed by 3 hours because 3 is D, 6 is T. What is N now? What is N you can calculate? N is equal to T by D. 6 by 3, 2. So I am delaying 3 hours because D is equal to 3. Storm 1 I am writing first for storm 1. How can I write? What can I write for storm 1? Any change? Any change shall I write? No, same values. 0, 4, 12, 15, 6, 0. Storm 1 UH values are same. Rainfall 2 UH values. Storm 2 UH values. I can delay na? I can delay for 3 hours. So that 0, 4, 12, 15, 6, 0. You understand? I am taking the values from third hour is 0, then after values provided. Before that neglected. Why? Because storm 2 is started at this point. For storm to any values before third hour. For storm to any values before third hour, there is no storm 2. There is no existence of storm 2 before third hour. Then why? What is the necessity to take the value? Nothing to take. So now 6 hour. What I am plotting now? What I can plot now? Tell me. 6 hour DRH. Because I am adding both, 6 hour DRH will come. 4, 16, 27, 21, 6, 0. Now 6 hour UH, this is our target, first target only. 6 hour T hour UH. 6 hour UH. How can I take? 6 hour DRH by N. What is N value? What is N value? Solved already. 6 by 3. N is equal to 2. Or simple. You are adding how many values? You are adding storm 1 value, storm 2 value. You can take 2 centimeter divided by 2. So divided by 2, I am taking 4 by 2. 2 meter cube per second. 16 by 2. 8 meter cube per second. 27 by 2. 13.5 meter cube per second. 21 by 2, 10.5 meter cube per second. 6 by 2, 3 meter cube per second. 0. So what is peak discharge of 6 hour unit hydrograph? Tell me. Peak discharge of 6 hour unit hydrograph. T hour. 6 is the T only, no? Peak discharge of T hour 6 hour unit hydrograph. 13.5 meter cube per second. What is peak discharge of 3 hour unit hydrograph? Given data. See the given data. What is peak discharge of 3 hour unit hydrograph? 15. This is only na. So peak discharge. Not only peak discharge, with respect to time you can take discharge values of 3 hour UH greater than discharge values of 6 hour UH for the same time. For the 3 hours, it is 4, it is 2. For the 6 hours, that is 12, that is 8, 15, 13.5, 6, 10.5, 0, 3. So that is varying. Peak discharge of 6 hour unit hydrograph is less than 3 hour UH. Clearly write down. Peak discharge of 6 hour unit hydrograph, 6 hour UH, less than peak discharge of 3 hour UH. Remember this one, very important. So T hour storm discharge, T hour unit hydrograph discharge, T hour unit hydrograph discharge less than D for Delhi, D hour unit hydrograph discharge. Okay, we'll move on. Now method of superposition completed. We are talking about S curve technique, S hydrograph. S hydrograph does not require any condition. S hydrograph does not require any condition. T may be not equal to ND, no problem. T may be less than D, no problem. T may be greater than D, no problem. You can plot any unit hydrograph using S hydrograph. For example, 3 hour unit hydrograph provided to you. Now you first plot S hydrograph. Convert this S hydrograph to 1 hour unit hydrograph. So T is less than D, na? T is 1, T is 1 now. D is 3. You can accept, na? 3 hour unit hydrographs to S hydrograph. S hydrograph to 1 hour unit hydrograph. Possible, na? Possible, na? So that is done. T not equal to ND, T less than D, T greater than D. For any kind of circumstances, S hydrograph can be applicable. But What is the condition? For uniform depth only. Applicable for uniform storms only. Uniform storms only. I will write down definition for S hydrograph. The direct runoff hydrograph. The direct runoff hydrograph of 1 centimeter. What we can call direct runoff hydrograph of 1 centimeter depth? What we can call direct runoff hydrograph of 1 centimeter effective rainfall depth? That is nothing but unit hydrograph. No? So, the unit hydrograph of S hydrograph is a form of unit hydrograph. The unit hydrograph of 1 centimeter occurred. Unit hydrograph of 1 centimeter effective rainfall occurred for d hours. Depth of 1 centimeter, time of d hours. What is intensity? Depth of 1 centimeter occurred for d hours. What is intensity? 1 by d centimeters per hour. 1 by d centimeter per hour. Intensity of rainfall. Intensity of rainfall occurred uniformly. Occurred uniformly over the catchment. Occurred uniformly over the catchment for the infinite period. For the infinite duration. For infinite duration. So long time. Infinite means long time. Infinite duration. What it results? Resulting equilibrium discharge. That is called S curve. Resulting equilibrium discharge. That is called S curve. Again I am repeating. A rainfall of 1 centimeter effective depth means unit hydrograph. Occurred for how many hours? D hours. Then what is intensity? Depth by duration. 1 centimeter for d hours. 1 by d centimeter per hour intensity. Happened for very, very long time. Infinite of time duration. Uniformly. Same depth. Uniformly over the catchment. For very long time. Finally it reaches to a constant discharge. Equilibrium discharge. That is analyzed through S curve, S hydrograph. That is analyzed through S curve, S hydrograph. I will show you. So again we are plotting for QUH on meter cube per second. Unit hydrograph discharges on y-axis. Time in hours happened for x-axis. I am writing time in terms of d ordinates. 0D, 2D, 3D, 4D, 5D, 6D like that. Now, first I am plotting first 1 centimeter d hour rainfall occur like this. Unit hydrograph, storm 1 unit hydrograph. Then storm 2 1 by d centimeter. It is delayed for d hours. No. Storm 2 1 by d centimeter delayed by d hours happened here. Storm 3 again delayed by 1 by d centimeter. Storm 4 delayed like this. It will continue like this now. Storm 5. So at some point if you add the values one upon another, values added one upon another, you can get a peak discharge value which is continued for long time. So if you add all the values of delayed unit hydrograph, if you add all the values of delayed unit hydrograph, you will get the equilibrium discharge QEQ. This QEQ equilibrium discharge is called, this QEQ equilibrium discharge is called S curve equilibrium discharge. S curve, S hydrograph discharge. S hydrograph discharge. QEQ. More than this, nothing required for your AE. I will give one formula, simple formula related to S curve discharge. QEQ or S curve discharge in meter cube per second is equal to QEQ or S curve discharge in meter cube per second is equal to 2.778 into A by D. A is area of catchment considered in kilometer square. A is area of catchment considered in kilometer square. D is duration of rainfall occurred considered in hours. Remember, you must take D in hours only, area of catchment in kilometer square only. Then you will get a discharge in meter cube per second. The reason behind that, why? Factor already multiplied for unit conversion, already factor given 2.778, so that you no need to multiply with any factor, no need to perform any unit conversion. Already converted units taken there. Area in square kilometer, duration of rainfall in hours you can take. 2.778 into A by D gives equilibrium discharge or S curve discharge. Okay. Other than this, nothing is required for S curve. This formula is most important for your AE exam. You have a simple numerical question. Then we have some more hydrographs here. Instantaneous unit hydrograph. Instantaneous unit hydrograph proposed by the scientist Clark. So it is also called Clark's IUH. IUH is instantaneous unit hydrograph. So instantaneous unit hydrograph proposed by the scientist Clark. So it is called Clark's IUH. What is this? Unit hydrograph of shortest duration. Unit hydrograph of shortest duration. We'll call it as zero duration. So what is the name given to zero duration? At that instant of time, point of time. Example, just now rainfall is occurring since long 6 hours. Just now I came, I am the hydrologist, just now I came. I picked up one value at this point of time and plotted unit hydrograph. Only I have taken one value of discharge, starting is 0, ending is 0, I have plotted unit hydrograph at this point of time. What is time gap? Exactly at this instant. So that zero duration, that is called infinitesimal or instant of time. Unit hydrograph plotted at an instant of time. Unit hydrograph plotted at an instant of time, infinitesimal. That is unit hydrograph of shortest duration, instantaneous unit hydrograph. Ordinate of instantaneous unit hydrograph. Where it lies? Ordinate of instantaneous unit hydrograph lies on. Ordinate of instantaneous unit hydrograph lies on slope of S curve. Remember this. Ordinate of instantaneous unit hydrograph of delta T hours. Delta T hours may be 0 also. Delta T hours that lies on slope of what curve? What curve it lies? Slope of S hydrograph, S curve. For example, I have plotted S curve. This is the S curve plotted providing equilibrium discharge, and I have delayed a certain time and plotted another S curve. This is SA and this is SB. Now the difference in a time delta t I have considered, the value must be within between SE and SB. So that lies on the slope of S curve. That is called instantaneous unit hydrograph. 2 points you need to remember here. Unit hydrograph of shortest duration is IUH, instantaneous unit hydrograph, and its ordinate resides set. Where resides? Slope of S curve. Okay, we'll move on. Last type of hydrograph, synthetic unit hydrograph. So you don't need any formula, anything related to it, because you are preparing for AE exam, AEE exam, not for GATE and IS. So just definition. Synthetic unit hydrograph proposed by the scientist Snyder. So you have a catchment which does not carry any rain gauge. Ungauged catchment. You have a catchment or some part of catchment without rain gauge. Ungauged catchment. You need unit hydrograph for it. Is it possible? If no rain gauge, no measurement of flood data, no measurement of rainfall occurrence values, discharge values, nothing measured. That is called ungauged catchment. But still you are having the desire, you want unit hydrograph for that catchment. Then what you will do? You are taking unit hydrograph data of some catchment of geometrically, hydrologically, meteorologically similar and comparing with ungauged catchment. So taking unit hydrograph data of gauged catchment and plotting unit hydrograph for ungauged catchment. That method is called synthetic unit hydrograph, artificially made. No natural values. You are not at all having any natural values. You are getting the values by comparing with already available gauged catchment. So the unit hydrograph of a catchment without rain gauges obtained using unit hydrograph of a catchment with rain gauge by the method. That method is called synthetic unit hydrograph. Clear? So we'll go to solve some objective questions here. A hydrograph of short duration can be converted into hydrograph of longer duration. Short duration hydrograph to long duration hydrograph. They have not mentioned any relation. Relation is mentioned, they have given T is equal to ND and all those things. We think what can follow? Nothing given. Nothing given, you go for S curve method. You can plot any kind of hydrograph, any time, any depth, whatever it may be. You always plot using S curve method. For a catchment area of 36 km square, area of catchment, the equilibrium discharge of an S curve obtained by 2-hour unit hydrograph. 2-hour unit hydrograph summation is A is 36 km square, D is 2 hours. Just now we discussed formula for equilibrium discharge of S curve. Tell me. QEQ. Tell me. Formula for equilibrium discharge of S curve. 2.778 into A by D. 2.778 into A by D. What is your A value? 2.778. Will you convert A kilometer square to meter square? Will you convert? No. Directly A in square kilometer, D in hours. 2.778 into 36 by 2. 2.778 into 36 by 2. This is the answer you are getting. 50 meter cube per second. So, equilibrium discharge 50 meter cube per second. Answer is option B. Answer is option B, 50 meter cube per second. A 3-hour unit hydrograph of a catchment has a P coordinate of 50 meter cube per second. 3-hour UH carries P coordinate of 50 meter cube per second. The P coordinate of 6-hour UH. What happened to time? Time increases. Which is more? 3-hour is more, 6-hour is more. We have written clearly. Do you remember? I will show it. I will show it to you. Clearly written. P coordinate of 6-hour UH is less than P coordinate of 3-hour UH. In the explanation of method of superposition, clearly we have written T-hour unit hydrograph P coordinate is less than T-hour unit hydrograph P coordinate is less than D-hour. What is the D here? D is 3, T is 6. So what happened now? What is the answer? Tell me. Less than, time increases, discharge decreases. Less than 50 meter cube per second. So answer is option C. Answer is option C. The duration of unit hydrograph approaches 0. Duration of unit hydrograph approaches 0. Resulting unit hydrograph. What is that? Instantaneous. Clark's IUH we discussed in 0 duration. Again about instantaneous unit hydrograph. An instantaneous unit hydrograph is formed when the duration of effective precipitation infinitesimal. Given clearly? Infinitesimal. Given option A, infinitesimal. 0 hour at a point of instant, that is instantaneous unit hydrograph. The P coordinate of 4-hour unit hydrograph. P coordinate of 4-hour unit hydrograph. 270 meter cube per second. Then P coordinate of 8-hour UH. Do you need anything to explain here? Already we have completed one model, 3-hour to 6-hour. Now 4-hour to 8-hour, tell me. Whatever it may be, increase in time, decreases discharge. Less than 270. Question is given just to know whether equal to, less than, more than. They won't ask. Because individual data not given. Value is needed. You need individual data. So value not provided. So we'll consider less than 270. Option B. Option B. Okay, my dear students, the session is finished. By this we have finished total concept of hydrograph. Hydrograph, more than this not required for your AEA. Thoroughly practice more and more questions. That is very, very important for you. Okay. In an academy, the English teaching faculty team, the best team in India we are having. Myself, I am going to teach you environmental engineering, hydrology, irrigation, open channel flow. RP sir, who is from NIT Trichy, having 10 plus years of experience, ex-ACE Academy faculty, he is going to teach all structural related subjects and transportation. The subjects he is going to teach will come for 25 marks in GATE examination. The subjects I am teaching also will give you 25 marks in GATE examination. And Abdul Rafi sir is expert for GT, well-known name for soil mechanics and geotechnical engineering. So we three will cover all the core related subjects to you. And for remaining top faculty in India available in an academy. So take full-length course GATE and ESE. Take full-length course of GATE and ESE using my code. Don't miss it. My code, don't forget it. KP Civil or Engineering Guru. Any one code you use, you will get all the benefits for it. If you have any doubt, call me, WhatsApp me, 8985931112. I am available for the student to clarify his doubts, to clarify his practice session, whatever the preparation doubts, whatever academic support I will provide you. Okay. So what are the benefits of using KP Civil Code? Using KP Civil, you will get 10% discount, free online test series, free study material and notes. So this material itself cost very high price in the market. Online test series itself high price in the market. I am giving you free online test series, free material, and my support and my panel of faculty support throughout your preparation of GATE and DSC. We are with you till you crack the GATE exam. Then why you are waiting? Join plus course in an academy using, very important, using KP Civil Code. Let's crack it.